Hello everyone, welcome to the sixth lecture in Chapter 1, Grade 11 Chemistry. What is a limiting reactant and what is a non-limiting reactant? What is the role of a limiting reactant in a chemical reaction? How does a limiting reactant affect the yield of the reaction? How does it affect the overall outcome of a reaction? These are the questions that we are going to answer in this lecture. So let's begin. So first of all, let's see what a limiting reactant means. Does it mean a reactant that is present in smaller quantity in grams? For example, we have a chemical reaction in which A reacts with B to yield C. Now, if you are asked to perform a chemical reaction between 10 grams of A and 8 grams of B, does it really mean that because B is present in smaller quantity, that is 8 grams, so B should be the limiting reactant? Not at all. That is not the case. So what is a limiting reactant? You can define a limiting reactant in a couple of ways. First of all, limiting reactant is a reactant that yields the least amount of the product. And by amount, we mean the number of moles. So a limiting reactant is a reactant that produces the least number of moles of a product. Or you can define a limiting reactant as a reactant that is completely consumed in the chemical reaction. So you can define it in both ways: a reactant that yields the least number of moles of the product, or a reactant that is consumed completely during the chemical reaction. On the other hand, a non-limiting reactant would be a reactant that yields larger amount of the product, that is the larger number of moles as compared to the other one, or it would be a reactant that is not consumed completely during the chemical reaction. In other words, some of the amount of the non-limiting reactant would be left at the end of the chemical reaction. And that is what we call an excess reactant. So in a chemical reaction, we might have a reactant that produces the least amount of the product or is consumed completely, and we call it the limiting reactant. Or we will have another reactant that is left behind after the completion of the reaction, or it may give a larger amount of the product. But that may not be the case in every chemical reaction. You might have chemical reactions in which there is no limiting or non-limiting reactant. So to find out whether we have or we don't have a limiting reactant in a chemical reaction, what we need to do? We need to first have the chemical reaction and then write a balanced chemical equation for that reaction. Determine the molar ratios from the balanced chemical equation, and then find out what are the molar ratios of the reactants given to us. If the given amount is exactly in the same molar ratio as can be seen from the balanced chemical equation, then we may not have, or we will not have, any limiting or non-limiting reactant. But if the given molar ratios are different from what we have in a balanced chemical equation, that is a case in which one of the reactant will be a limiting reactant and the other would be a non-limiting reactant or an excess reactant. Let's see this with the help of an example, and then we will solve a couple of examples from your book. So for example, we have a chemical reaction between carbon and oxygen that produces carbon dioxide. So let's see if this chemical equation is balanced or not. So on the left hand side we have one carbon atom, on the right hand side we also have one carbon, On the left, we have 2 oxygens, and on the right, we have 2 oxygens. It's a completely balanced chemical equation. Now, if somebody tells you that 10 grams of carbon are going to react with, say, 15 grams of oxygen to produce carbon dioxide. So, just from these amounts given in grams, do you think carbon is the limiting reactant? No. We have to first find out the molar ratios between carbon and oxygen based on the information from the balanced chemical equation, and then decide which of these two will be the limiting reactant. So from the balanced chemical equation, we know that 1 mole of carbon reacts with 1 mole of oxygen to produce 1 mole of carbon dioxide. So for 1 mole of carbon, we would need 1 mole of oxygen. Now what we are given? We are given 10 grams of carbon. So first we have to find out the number of moles of carbon given to us. You already know the equation from which you can find out the number of moles, that is the mass in grams divided by the molar mass, that is 12 for carbon. So 10 divided by 12 is equal to 0.833 moles. Now, from the balanced chemical equation, we know that the molar ratios between carbon and oxygen are 1 1. So, 1 mole of carbon reacts with 1 mole of oxygen. So, if we have 0.833 moles of carbon, we would need 0.833 moles of oxygen to have a complete reaction in which both the reactants are consumed completely to produce carbon dioxide. Now we have to calculate the number of moles of oxygen given to us. So the mass in grams is 15, and you know that the molar mass of oxygen is 32. Now this is equal to 0.468 or 0.47 moles. Now for 1 mole of carbon, we need 1 mole of oxygen. So for 0.83 moles of carbon, we would need 0.83 moles of oxygen. Or you can say that for 0.468 moles of oxygen, we would need 0.468 moles of carbon according to the molar ratios from the balanced chemical equation. So for 0.833 moles of carbon, we need 0.8 moles of oxygen, but we have 0.47 moles of oxygen, which means that we have lower number of moles than what are required to react with 0.83 moles of carbon. Or in other words, if we have 0.468 moles of oxygen, we would need 0.468 moles of carbon, but here we have 0.833 moles, so we have carbon in excess of what is required to react with 0.468 moles of oxygen, which means that carbon here is in excess and oxygen is the limiting reactant. So oxygen is the limiting reactant and carbon is the non-limiting reactant or the excess reactant in this case. But if you look at the amounts given in grams, you see here we have 15 grams of oxygen. That may mislead you to a wrong answer in the exam. So first you have to find out the number of moles or the molar ratios from the balanced chemical equation, then calculate the number of moles of the reactants from the amount given in grams, and then find out which one is the limiting reactant. Now let's see another scenario for this reaction. If we have 6 grams of carbon and 16 grams of oxygen, and you're asked to calculate the amount of carbon dioxide that would be produced, or if you are asked to determine which of these two is a limiting or non-limiting reactant. So what we saw in the previous scenario is that 10 grams of carbon still made it the excess reactant as compared to 15 grams of oxygen. And now we have 6 grams of carbon and 16 grams of oxygen. Do you think carbon again would be the excess reactant as from the previous scenario? Let's see, let's find out from the molar ratios. So 1 mole of carbon reacts with 1 mole of oxygen in this chemical reaction. So the number of moles of carbon given to us are, that is the mass in grams, 6 divided by 12, this is equal to 0.5 moles of carbon. And the number of moles of oxygen given to us are, mass in grams, that is 16 divided by 32, that is the molar mass of oxygen molecule, and this is also equal to 0.5 moles of oxygen molecule. Now you see that we have equal number of moles of oxygen and carbon given to us. And from the balanced chemical equation, the molar ratios are 1:1. And if we have equal number of moles of carbon and oxygen given to us to react together, it means that the molar ratios are 1:1, which is exactly the same ratio as we can see in the balanced chemical equation. So 6 grams of carbon will be consumed completely by reacting with 16 grams of oxygen, which itself will be consumed completely to produce carbon dioxide. And so in this scenario, there is no limiting or non-limiting reactant, because none of these reactants is left behind or none of them is consumed first. The next question is, why would we bother finding out a limiting or a non-limiting reactant? Or what is the role of limiting or non-limiting reactant in a chemical reaction or in stoichiometry? So it is the limiting reactant or the amount of the limiting reactant that decides how much product will be produced as a result of a chemical reaction. So whenever you are asked to do stoichiometry for chemical reaction, you need to first find out which of the two reactants is the limiting reactant, and then do the calculations, do the math from the amount of that particular reactant that is the limiting reactant in fact, and then you will get the actual amount of product that could be produced as a result of that chemical reaction. Because if you do the calculation from a non-limiting reactant, then of course you will have a larger quantity of the product for which the amount of limiting reactant would not be present there, and that is not practically feasible to have that amount of product if you have the limiting reactant in lesser quantity. Now let's see this again with the help of an example. Again, if you have the same reactants like carbon and oxygen and you produce carbon dioxide, let's have the same scenario in which we have 10 grams of carbon and 15 grams of oxygen. Now if you are asked to first find out the limiting reactant in this case and then calculate the amount of carbon dioxide that will be produced as a result of this chemical reaction. So if you remember from this scenario that we had previously, the number of moles of carbon given to us are 0.833, and the number of moles of oxygen given to us are 0.468. From the balanced chemical equation, we know that the molar ratios are 1:1. That is, 1 mole of carbon reacts with 1 mole of oxygen to produce 1 mole of carbon dioxide. If you determine the molar ratio between carbon and oxygen that are given to us, it's not equal to what we have from the balanced chemical equation. That is different from 1:1. Because for 0.83 moles of carbon, we would need 0.83 moles of oxygen, which are not present here. Or you can say that for 0.468 moles of oxygen, we would need 0.468 moles of carbon. And in fact, we have carbon in excess here, which makes oxygen the limiting reactant. Now let's see the use of the limiting reactant. For example, we do the math or the stoichiometry from carbon. That is the non-limiting reactant. So from the balanced chemical equation, we know that 1 mole of carbon will produce 1 mole of carbon dioxide. So 0.833 moles of carbon will produce 0.833 moles of carbon dioxide, which is equal to 0.833 multiplied by the molar mass, that is 44, 36.6 grams of carbon dioxide. Now this means that if we have 0.833 moles of carbon and we do the stoichiometry from carbon, then of course we should have 36.6 grams of carbon dioxide. And to produce 36.6 grams of carbon dioxide, these 0.833 moles of carbon have to react with 0.833 moles of oxygen, which are actually not present there because we have 0.468 moles of oxygen, not 0.833. So practically, the formation of 36.6 grams of carbon dioxide is not possible. But let's see this calculation from oxygen. So if we do the math from oxygen, that is the limiting reactant in this case, we know that as 1 mole of oxygen will produce 1 mole of carbon dioxide. That is from the balanced chemical equation. What we have in hand is 0.468 moles of oxygen that, according to balanced chemical equation, should produce 0.468 moles of carbon dioxide. And this is equal to 44 multiplied by 0.468, that is the number of moles of carbon dioxide produced, which is equal to 20.59 grams. So if you remember, when we did the math from carbon, we had 36.6 grams of carbon dioxide. But if you do the math from oxygen, then we should have 20.59 grams of carbon dioxide. So what does this mean? In the start of the lecture, we defined limiting reactant in two ways. The first one is that limiting reactant is a reactant that is present in lower molar ratio, or you can say that in lower number of moles. So if you see from here, we have carbon equal to 0.83 moles and oxygen is 0.468 moles. So the number of moles of oxygen are lower in this case, so oxygen should be the limiting reactant. Secondly, the limiting reactant is a reactant which produces a lower amount of the product. So from carbon, we should have 36.6 grams of carbon dioxide produced as a result, and from oxygen, we will have 20.59 grams of carbon dioxide, and that makes oxygen the limiting reactant. Now, the importance of the limiting reactant here is that in this chemical reaction and in this scenario in which we have 10 grams of carbon and 15 grams of oxygen, we can only have 20.59 grams of carbon dioxide produced as a result, max. And we can never have 36.6 grams of carbon dioxide. Why? Because to produce 20.59 grams of carbon dioxide, we must have 0.468 grams of oxygen as well as carbon under this scenario, and we have the same number of moles present for both of the reactants. But to produce 36.6 grams of carbon dioxide, we must have 0.83 moles of both the reactants. We have 0.83 moles of carbon, but we do not have 0.83 moles of oxygen, which means that practically the formation of 36.6 grams of carbon dioxide is not possible. And which means that calculation or stoichiometric calculation from carbon is wrong, but stoichiometric calculation from oxygen is right, and oxygen actually is the limiting reactant. So whenever you are going to perform stoichiometry or do the math, you should do it from the limiting reactant always, because that will give you the correct amount of product that is produced as a result. Because you just saw that if we calculate from carbon, we will have a larger number of moles of carbon dioxide, but we cannot have that because we do not have the required number of moles of the second reactant. And what that means as a result is that when we have 0.468 moles of oxygen, it will only react with 0.468 moles of carbon, which means that some amount of carbon will be left behind, and that is the difference of what we have in hand and what has reacted with the limiting reactant. So if you take the difference of both of these, this is equal to 0.365 moles of carbon that are left behind after complete chemical reaction. And if you convert these 0.365 moles into mass of carbon, so you multiply this with 12, that is equal to 4.38 grams of carbon, which means that if we have 10 grams of carbon, 4.38 moles of carbon are left behind. So what has actually reacted with oxygen is equal to 5.62 grams of carbon. So 15 grams of oxygen reacts with 5.62 grams of carbon to produce 20.59 grams of carbon dioxide. Now that is the importance of finding out the limiting reactant in a chemical reaction and then doing the math from the number of moles of that particular reactant, getting to the correct yield of the product. So in this case, 5.62 grams of carbon reacts with 15 grams of oxygen to produce 20.59 grams of carbon dioxide. 4.38 moles of carbon are, 4.38 grams of carbon are left unreacted, which means that carbon here is in excess and it is not completely consumed during the chemical reaction. Stay tuned for the next lecture, in which we will solve a couple of examples related to limiting and non-limiting reactant from your book. So see you next time with those examples. Thank you so much.